Welcome to Science Access. In today's class, we'll be talking about the pressure law. Now, the pressure law states that the pressure of a fixed mass of a gas is directly proportional to its temperature, provided the volume remains constant. Now, we're going to highlight the parameters in this definition or in this law. We have the pressure, have the mass, we have the temperature, and we have the volume. Now, note this fact. Fixed mass, it simply means that the mass is constant. Volume remain constant. It simply means that the volume is constant. So pressure is directly proportional to temperature when the mass is constant and the volume is constant. Note that. So we can now state that pressure is directly proportional to temperature. Now, if you want to change this sign of proportionality to equal to sign, you have to introduce a constant. So we can now state that P is equals to K, which is the constant, then T, temperature. Now, let's make the constant the subject of formula. That means we want to make the constant to be on its own. How do we do that? To make this K to be on its own, we have to divide both side by T. Remember, if you divide this side by T, this T will cancel out the T at the bottom so that K will now be on its own. So that's what we did here. P all over T, then K, T all over T. Then this will now cancel out this. So we now have PT is equals to K, or we can put it in another way, or K is equals to PT. It's the same thing. Now, so we now have, this is pressure all over temperature, or pressure divided temperature. In some cases, we have two pressure and two temperature, which is the initial pressure and the final pressure, the initial temperature and the final temperature. In that case, we can now relate the first to the second. Pressure 1 all over T1 is equals to P2 all over T2. P1 all over T1 is equals to P2 all over T2. So you are relating the first pressure, the initial pressure, and temperature to the final pressure and temperature. So this is the formula that we use to calculate the pressure law. So let's take this question. Take the first example. At constant volume, if the pressure of nitrogen gas at 25 degrees is this, so the initial temperature is 25 degrees Celsius and the initial pressure is 3 atmosphere. So we have P1 as 3 atmosphere, we have T1 as 25 degrees Celsius. Calculate the pressure. So they're asking you to calculate for the P2, which is P2 is equals to, that's what you're asked to calculate, when the temperature is increased to 100 degrees Celsius. So the T2 is actually 100 degrees Celsius. So we now know the P1 as 3 atmosphere, the T1 as 25 degrees Celsius, the P2 is what we're looking for, and the T2 is 100 degrees Celsius. Now remember our formula here. To calculate that, we have to put P1 all over T1 is equals to P2 all over T2. You have to cross multiply because you want to make P the subject of formula. So I'll cross multiply. Now I'll use this P2 to multiply T1, which we have P2. We now have P2 T1. And I'll use this to multiply this. We now have P1 T2. Remember, we want to make P2 the subject of formula because we are looking for P2. So in order to make P2 to stay on its own, I will divide both sides by T1 so that this one will leave this place. So we now have P2 T1 all over T1 equals to P1 T2 all over T1. Now, we can now use this to cancel out this. So we now have P2 is equals to P1 T2 all over T1. So this is the formula that we're going to use to calculate for P2. Now, take a look at this. Let's take a look at this. P2 here. P1, what is P1? 3. T2, 100. So we now have 3 times 100. What about T1? 25. All over 25. All right? So if you use this to multiply this, you have 300 all over 25. Now, if you use 25 to divide 300, what will you get? You have 12 atmosphere. In some cases, the final answer may not be given in atmosphere, it may be given in other units. So you have to learn conversion of units, both in temperature as well as in pressure. You can check my video on conversion of scales in temperatures as well as in pressure. Now let's take question number 2. Now, question number 2, the pressure of chlorine gas at 283 Kelvin, remember this unit here is Kelvin, not degrees Celsius, is 1.5 atmosphere. Calculate the temperature in degrees Celsius. You are not asked to calculate the temperature in degrees Celsius, not Kelvin, if the pressure is reduced by 1/3. Okay, assuming the volume is constant. So P1, remember we have chlorine gas at 28, then this is P1. 283 Kelvin is 1.5. So 1.5 is our P1. If you want to change it to fraction, you can just use 2 to multiply both the numerator and the denominator. You now have 3/2. All right, but you can use this since you're using your calculator. Assuming you're not using your calculator, you're doing an exam without calculator, you can decide to use this. Okay, so what about T1 at 283 Kelvin? So this is T1. What about P2? P2 states that if they said you should calculate the temperature in degrees Celsius if the pressure is reduced by 1/3. 1/3 is 1/3. So the P1 is 3/2. Now you are reducing it by 1/3, right? So you divide it by 3, or you simply multiply it by 1/3. So if you do that, you have, let's do something here. 1/3 is 1/3, right? So if you use it to multiply this, you have 3. If you use it to multiply this, you have 6. Now, 3 can go into this is 1. 3 can go into this is 2. So that's how we have 1/2 here. Another way you can write 1/2 in decimal form is actually 0.5. So you can decide at the beginning to just use 3 to divide 1.5. Remember, it's 3 that is actually dividing this. So you can use 3 to divide 1.5. You also get 0.5 because 1/3. That means you are dividing it by 3. So please take note. Why the final temperature you are being asked to calculate in degree Celsius. So take note of that and note the way I did this. If you're confused, you can always ask in the comment section. I'll reply you. All right. Now the formula, as usual, is P1 all over T1 equals to P2 all over T2. Now, so based on the fact that we're looking for temperature 2 or the final temperature, I'll use this to multiply this. We now have P1 T2 equal to T1. If I use this to multiply, you now have T1 P2. Now note, the reason why I'm putting T2 this way is because we are actually looking for T2. Assuming we are looking for P2, I will put this is equal to this. Now putting the one we are looking for at the left-hand side. All right. Once you have this, you can decide to make this T2 that you're looking for the subject of formula. How will you do that? Just divide both sides by P1 such that this will cancel out this. Divide this side by P1, that's what we did here. We divide this side by P1, that's what we did here. So this will cancel out this. I'll now have T2 is equals to T1 P2 all over P1. Then once you have gotten this, you've gotten the formula to calculate for the question. So what is T1? T1 is, we have it here, 283 times, what is P2? P2 is 0.5. 0.5 all over, what is P1? P1 is 1.5 all over 1.5. So if you use this to multiply this, you have this, divide 1.5. So if you carry out the division, you have 94.333 Kelvin. Remember, you are asked to calculate for the temperature in degrees Celsius, not Kelvin. So the answer you got here is actually in Kelvin. So how do you calculate for temperature in degrees Celsius? This is the formula. So it's simply the temperature you got minus 270. So degrees Celsius is equal to T. What is your T? Which is the one here, 74.33 minus 270, which we have here. If you carry out the subtraction, you have this as your answer, minus 178.67 degree Celsius. So this is your final answer. So it's a very simple question. Another assignment is being displayed on your screen. Just solve it and drop your answer in the comment section. I'll reply you if it's correct or wrong. Thank you.